You may have seen this story covered in the media recently, and those eagle-eyed followers among you will have known that this was coming. I've touched on it following some conferences recently, and a number of people have sent this article to me asking for some context. And so it seems like now would be a helpful time to do a deeper dive into the topic to get some overall context and what it all means for individuals without perfect hearing and for society as a whole. I'll start by saying this. On a generational level, this is remarkable science. The kind of thing many of us never thought possible in our lifetime. An absolute hats off to my colleagues in Cambridge who have been at the heart of this multinational work. I've had the privilege to talk to them firsthand about this. Obviously hold them in the highest regard, and respect to that little girl's parents too. It takes a lot of bravery for any parent to enrol their child in a world-first trial. But I know that these news articles will often pick out the most exciting aspects, and I suspect that will leave many people wondering, what does it mean for their individual situation? What does it mean for all people living with deafness? Is it all too good to be true? Do we need to exercise some caution and sensitivities? Well, let's get into it, starting with some A-level biology to get some context. The way we hear is as a result of our ears having a conduction system connected to a microphone system. Now, problems with the conduction system can often be reversed by a surgeon like me, but until now, we've never been able to do quite the same with the microphonic system. Hearing aids and cochlear implants are great at compensating for hearing losses, but remember that digitized sound can never be expected to truly replicate natural acoustic hearing in terms of sound authenticity and therefore listening effort. Now, there are loads of reasons why someone's microphonic system might lead to them being deaf, and these include bacteria, viruses, premature birth, neonatal difficulties, certain maternal conditions, the necessary use of life-saving antibiotics, and the focus of this story, genetics. To understand this more clearly, it's worth having a look at the anatomy of how the hearing system works. Inside the bony snail-shaped shell known as the cochlea, there are thousands of microscopic hair cells housed in fluid. And these hair cells deflect when the fluid is moved by sound, and that deflection leads to the generation of electrical current down the hearing nerve towards the brain. Now, each hair cell itself has hundreds of hairs and is connected to nerve endings. And the whole mechanism is made up of many protein subunits, building blocks if you like. And there are hundreds of genes in each of us that give the body the correct instructions to build one or more of these building blocks, which make up a working hair cell system and nerve ending interface. And so one little change in any of those many genes can cause the whole current generating system not to function, thereby leading to deafness. Now, of those many hundreds of genes, one specific gene known as OTOF, which codes for the protein otoferlin, has drawn specific attention because it's a single gene coding a single protein in the hearing system. And that's made it a prime target to see if gene therapy can work at all. And so it's OTOF that's been the focus of the trial in Cambridge and Philadelphia. Otoferlin has a role in the inner ear's interface with the hearing nerve. And so a change in it leads to something called auditory neuropathy. And so this treatment to create hearing ability in a non-functioning system involves the use of a viral vector to deliver the missing information needed for the body to build that missing building block and enable the inner ear system to work, which subsequently opens up the potential for authentic music appreciation and development of verbal language without the use of devices, so long as it's done young enough and that the hearing is maintained in the long run, something that we will obviously have to wait to find out. And so this is remarkable because it's the first time in history that it's been possible to create the ability to hear naturally in this kind of way, in someone whose inner ear was otherwise never going to function. And it's absolutely right that the science media is excited by this. And to all of us involved in hearing restoration, this is major news. But it's also important to recognise in the same news articles that this therapy is an option for a very small proportion of people affected by deafness. So my hope is at the same time as us being amazed by this, that this excitement does not give any painful false hope or change the focus around deaf communication needs. For the many millions of people out there who are deaf by another non-genetic cause, or whose genetic deafness is unlikely to be helped by a single gene, single protein therapy that may or may not arrive in the coming years. We're still a long way from all of that. I do think realistically we can expect, on the basis of this recent trial, for therapies for a further few specific genes to come to human clinical trial in the coming years. Now, there's another thing to touch on here as well. I can imagine that the words cure for deafness are likely to be very triggering for many within the deaf community, which includes millions of people around the world. And I can understand why that is. It is absolutely possible to live a full and enriched life without reliance on verbal communication. Through the use of sign language and other modalities, we have a thriving deaf community within the UK and internationally, and many within that would not see deafness as something to be fixed or cured, rather something that actually brings them together and makes them unique. And furthermore, and the crucial bit, is that anything that might change that may risk downstream consequences on the way society sees and treats deaf people. And tied in with that is how much funding and normalisation there is for deaf provision, for deaf education, for sign language education, communication and the sort of deaf awareness that I've spoken about on this channel. And based on everything I've hopefully explained so far, it's clear that deaf people are going to be here, part of our society, and always will be. And so the priority given to societal inclusion and provisions for deaf people should not change. Whatever the differences in opinion on this are, my summary of it all would be this. This new type of therapy potentially opens up options. Potentially life-changing options for the small number of parents with children affected by these specific genes. The majority of children born deaf all over the world have parents who are in the hearing world and working in the hearing world. And many, I'm sure, would love to be able to have verbal conversation with their children. Now, taking up the option of learning sign language is a wonderful and beautiful communication option for those parents. But at the same time, we should remember that it won't necessarily be feasible for everyone in that situation, especially, for example, parents who are just about grasping fluent English when they've moved to a foreign land. And so therefore, options for hearing and therefore communication are always going to be helpful. We don't want any child out there to be left in a state of communication deprivation. And yet, as a society, we really should not change the value we place on being more inclusive, on embracing differences, and making society accessible for all. And I think we can celebrate that, and at the same time, celebrate the options that this remarkable science might open up in the years to come.